Okay, welcome back. So example 3. Given the following parabola, can x minus 1, x plus 2 be used to represent this parabola? Well, we can tell a couple of things here. First of all, it's positive out here. There's no negative number out here. So this is positive. So it opens up. So far, this says it should open up, and this does open up. So those two are good things. Next, if we look at this, the x-intercepts are going to be 1 and negative 2. Well, the x-intercepts over here are negative 1 and positive 2. So no. These x-intercepts do not match up. Okay? These x-intercepts are 1 and negative 2, so that would be here and there. Next question. Can y equals negative x squared minus x minus 2 represent this? So each one of these we're going to be asking, can the equation represent the graph that we have? Well, let's take a look. I'll try a different color. Let's see how my blue's working now. So it's negative here, so it opens down. Well, this opens up. So no, does not match graph. I don't have to look at anything else. The graph opens up. Look at the graph. The graph has, maybe we should say that, the graph has opens up, which means a must be greater than 0, and it has x-intercepts. The x-intercepts here are negative 1 and 2, which means that it needs to have a value, if we're going to put it in this form, of plus 1 and negative 2. So it needs to look something like this. We don't know what the a value is, but I know this much so far. So let's go farther. Can y equals x squared minus x plus 2 be used to represent this parabola? Well, the a value is positive, so opens up. So far so good. And this has a y-intercept of 2, which means it needs to cross at 0, 2. No, does not match graph. The graph, if we look at it, has a y-intercept of here. So it has a y-intercept of negative 2, which means it would cross at 0, negative 2. So these are all the things that have to work, and none of these are working for that. So D, can this graph be represent the parabola? Well, last one. A is greater than 0, so it opens up. So that's good. And it has x-intercepts of negative 1 and 2. That's good. And the last thing we need to check, though, is the c value. Okay? Because to do that, we need to expand this. So check the y-intercept. We need to expand. So x times x will be x squared minus 2x plus x minus 2. X squared plus x minus 2. We have a y-intercept of negative 2, and that matches the graph. So all three things match. So the answer is a resounding yes for that one. But notice you had to check all three things. You have to check the direction of opening, you have to check the x-intercepts, and you have to check the y-intercept. And that's done by expanding here. Example 4. The curve formed by a rope bridge can be modeled by the relation y equals x squared minus 11x plus 10, where x is the horizontal distance in meters and y is the height in meters. Write the relation in factored form. So factored form looks like this, where r and s are the x intercepts. They've given us it in standard form, so we need to factor it. So, taking a look at x squared, I grab a piece of scrap paper to do this. And I think I found it right off the bat. It's going to be 1 and 10. They add to give 11. Now it's going to have to be negative 1 and negative 10, but this will be x times x is x squared, x times negative 10x, negative 1x, plus 10. These two are like terms, x squared minus 11x plus 10. Yay! So this is going to be y equals x minus 1, x minus 10. We've put it in factored form. What's next? What are the zeros? Well, the zeros are going to be x equals 1 and 10. What that means is that we have a parabola that opens down and it's crossing the x-axis at 1 and 10. So it looks something like this. 1, 10, and it opens down. The axis of symmetry has to be halfway between there. So it's looking something like this. I don't know where the vertex is. Now I could do better because I know what the y-intercept is. But this is just a rough sketch. If I did include this, then my rough sketch would be better, and it would look something like this maybe. No, let's leave that alone. We'll come back to that. What is the horizontal distance from one end of the bridge to the other? So if this is our bridge, the horizontal distance from one end of the bridge to the other is going to be this distance. So that's the difference between 1 and 10, so that'll be 9 meters, because it's the difference between 1 and 10 meters horizontally. Okay, that's it. There's some homework for you to do, and we'll come back and we'll see you in a couple of days.